1, 2, 3. 1, 2. 1, 2, 3, 4, 5. Okay, good. All right, and also record the blue button. Okay. You know you're going to have a test on Friday. It's going to be approximately 30, 35 minutes, a few concept questions and a few walkthroughs. Walkthroughs are only one line, generate only 3, 4 characters. They're not small code snippets just to see you understand and grasp the idea. The concept questions are from the first 5 weeks. Whatever you see on the notes, I put it already in the description of the thing, of the midterm. Multiple choice, fill in the blanks, things like that. Just get an idea that you know what the concepts are. That's that. So today we are going to talk about files. So we're going to understand how the files work in C++. And also there is something that I want to teach that I think it's not in the notes. So I prepared an MD file separate for it, and I'm going to put it in the notes for today. That is the file system. So it's something after C++ 17 that helps you manage files using C++ in a platform-independent way. So you don't have to worry about if you're on. Like, for example, if you want to know what are the list of the files in the current directory, what is the path, create a directory, remove a directory, things like that. These are not specifically directly manipulating file with respect of the content of the file, but managing the file. If I have time, I will get to it today and explain it. If not, we'll cover it after the test. Yeah, and I'm going to need markers today when we get to indexing and stuff. Anyways, let me open up my cheat sheet. I've prepared a long list of things to go through. Sorry, poll didn't work. Give me 2 seconds. One more time. That's better. Okay. So let's talk about files. I'll start with what we actually deal with when we are dealing in OOP345, and then we're going to kind of dig it a little deeper. Let me prepare these things. Okay. Perfect. First thing first, writing in a file. We know how we write in files, and we learned it in OOP345 that you create an instance of type OStream, and the OStream you are creating essentially is a child of iStream. It's a child, OF stream, that is a child of OStream, that is a child of iOS. If we look at the subject notes on the matter, it's a good idea if I open it actually. If I go to content of files, we have a perfect diagram over here in the notes that explains everything. So this is essentially the hierarchy of input-output system. We have an iOS base, which is essentially all the constants and things and values that a file needs to have commonly to deal with wires. We have basic input-output system that actually deals with the low-level input-output. iOS is the input-output system, C++ implementation of it. iStream and OStream is the C in and C out that you're working with. These are classes that cannot be instantiated. You cannot instantiate iStream or OStream. They are privately instantiated to C out, C error, C log, and C in. So C out, C error, and C log are OStream, and C in is iStream. Okay? I cannot call it a singleton because there are 3 of them, but it's kind of a singleton. Anybody knows what is a singleton? You don't know what a singleton? Singleton is a type of a class that you can only instantiate it once. You cannot instantiate it more than once. You can only have one object out of it. Something like that. Anyways, don't quote me on that, though. Then iStream and OStream are inherited in IOStream, which essentially IOStream, which essentially is input and output together, and out of that one comes FStream. But most importantly, iStream has a child called IFStream, which is essentially C in, but instead of a terminal, you have file. Any input that you have done from that, you can do this one. And we have OFStream, which is essentially the C output for file. So any output you do, it's with file. That's why anything we have used in OOP345NAA output on the screen, we cloned it, we replicated it, and we use it to write in a file. We didn't even overload anything for it. We overloaded our objects to do print on C out, and we use that to actually write in a file because OFStream is a child of OStream. Therefore, through the model of virtuality and polymorphism, the latest version of the output will be called, therefore, instead of a screen, it's going to go in a file. We know that. And FStream is we have the FStream that is actually an outcome of IFStream and OFStream, which allows you to open a file for reading and writing at the same time. We got down to this point, so that's the whole picture of the file system. Read it later on, but let's see actually how it works. So when you instantiate a file, OFStream, and you name it, essentially, it does everything in the constructor. If you just create an instance of OFStream with no arguments, it creates a file that is not assigned. It creates a file object that is not assigned to a file on the hard drive. So instead of having OFStream file num.txt in a constructor, we could have had OFStream file, then file.open. Well, because it's an object-oriented thing, obviously the person who wrote it and says, OK, if they actually provide the file name, I'm going to open it to the constructor. As easy as that. And you don't have a close for your file as you did in C. Why? Because we have a destructor. Because we have a destructor, the file gets closed automatically. But if halfway through you want this file to switch file to another file on a hard drive, you can simply close it and open another one. So you can reuse the file to deal with multiple files, but not at the same time. Are we cool about this? Yes?
So if you want to switch files, then you'd have to use the close.
Then you have to?
Use the close?
Yeah, exactly. You close the other one, you open the other. It's exactly like boxes. Like whenever you're dealing with a box, you have a box, you have to open, see what's going on, then close it. It's always like that. And then you close it, set it aside, you open another box. You can do it all the time. Are we okay with this? So I'm going to use the exact same thing that I had, like the features that its mother has, which is essentially OStream. Therefore, I'm going to use the exact same insertion operator that we had for OStream and write in a file as if I'm writing in a cout, and put a space between them. Running this program will essentially create a nums.txt. We have different methods of opening. Append stuff, please go read it. You can open a file for append. So next time I open it, it doesn't create it. And whatever I add to it, it adds to the end of the file. Okay? Things like that. Please go over it and read it later on. The ways that you open a file, go through it and come with questions in the lab. Anyways. So if I run this program, obviously after this is created, nothing's printed, obviously. And what I will have over here will be nums.txt, which is essentially a series of double numbers in a text file. You good with this? Pardon me?
Can you run it one more time?
Yeah, sure. So just to show you, I'll do this, and I'll save it. Now I'm going to open it. Because it's open, it's opening with just the name of the file. If the file exists, it overwrites it. If I wanted to, I could actually add an iOS append, and it would have append to it. iOS scope resolution append. You have the list at the bottom of. Should be here somewhere. There you go. You see? So you don't need to write iOS space. Just write iOS in opening. Out, append, trunk, open, but wipe out the content. At end, open initially to write at end or read at end, but you can move it later on, bring it to the big halfway through and write halfway through a file. We'll find out soon how to do random access file. So files, you can write halfway through it. With append, you have no choice. It's always at the end. At end is initially at the end, but you can write everywhere. Binary, it's because of silly operating systems like Microsoft, which have different types for files. Text and binary, like in all the operating systems like Linux and Mac and all Linux-based operating system, everything is binary. Why you should, you know? If you go read the history of text and binary transfer of data, you'll see. That's why still when you're using FTP from Windows to Linux, you have to actually select what is the type of the thing that you are transferring. Otherwise, you're going to end up with some garbage in like some extra characters at the end of your stuff when you are actually uploading to Linux, okay? That's because text files are dealt with a little differently, but everything's binary in Linux. Anyways, forget about that. If you want things to happen in a certain way, you can combine these things separated with a bar. This bar is a binary OR. You're going to find out at the end of the semester what does it mean, okay? So you are saying iOS. This doesn't mean OR, okay? This doesn't mean conditional OR. I'll be here or I'm going to go there. That's an exclusive OR. Like you're going to say, it's not an OR that you have. It is a binary OR, so it doesn't mean really OR. Yes?
It's basically like a transistor or electronic OR. It's closer to that.
Yeah, but that's going to confuse the heck out of everyone. So it's a binary OR. We'll find out later on. But anyways, in this case, it means AND, which means I want to open for input and output. You put a bar between. Later on, I'll explain to you why OR over here means AND. But it doesn't mean AND. Don't quote me on that again. When we come at the end of the semester, you'll find out what is this thing doing. So I want to open for input and output, but if file has data, delete it first. Truncate. So open for input and output, but make sure it's always outputs at the end. open for input and then open for output, and wipe out everything, which is essentially the same thing as open without truncate, and so on and so forth. Anyways, you can go through it and see it. Okay, so I was halfway through executing that. I'm going to go back in here. So now I have the vector over here, and I'm going to write the first one with a space, then write the second one with a space. Because it's extract insertion operator, it's going to convert it to text and print it into a file as a text. And when it ends the program, the file closes, and therefore the file you have will have this content. You see the content is gone. So it essentially writes one space, space, and we have a space at the end that you don't see in here. Are we all good about this? Questions? This is OOP345. Now I'm going to do something else. I'm going to say, I want to write in here as binary now. So I want to write binary. If I run it like this, it's not going to make any difference. It's still going to write text. Opening the file for binary doesn't mean anything. Okay? It doesn't mean, like, if I actually run this now, the outcome's still the same, because it's the insertion operator that is converting to text and writing the text. That's why I told you there is no binary or text. Everything's binary. We don't have anything called, okay? So that's not the case. Let me just remove it first and save that thing as. This is, what do I call it? A text out.cpp or text write.cpp. So I'm going to make it binary now. And in here, instead of using the insertion operator, I'm going to ask the file to write. I'm going to ask the file to write. And when I tell to the file write, where am I going to tell? What am I going to tell write? I have to say write from the address of where V is, and write V bytes after that. So I'm saying go to the address of the beginning of that variable, wherever it's in memory, byte by byte, write the contents as a bit pattern inside the file, this many. So this is essentially a loop for I equals to 0 and characters of this, one by one, run it until you reach to the size of that one. And we know size of means the number of bytes that I have in V. V is doubles, therefore it's 8. Are we good with that? Are we okay with that? Now, the problem is that this is something that I could never understand about the person who wrote the write. I could never understand why they did that. We talked about pointers, right? And we learned what void pointers are, correct? And we said void pointers are typeless pointers, which essentially they don't have a type. So you don't have to cast. You can just pass it through, right? Problem with this thing is that they wrote the write, but they said you have to pass character address to it. Why not just void? I don't know. But write receives constant character pointer, because probably it wants to have an emphasis to tell you that I'm going to write byte by byte to make sure. Yeah, because it's a byte, right? A character is a byte. Yeah, exactly. Yeah, but they could have just received void and then cast void to byte. But anyways. I don't know. Well, I have no idea why they did that, but hey. So then I have to say over here, reinterpret cast into const character pointer the the V thingy, and now everything's good. Obviously, if it was old times, we would just write over here const character pointer and cast it, right? But we want to have a safe casting. So and because a double pointer and a character want two different beasts, I have to reinterpret the whole thing. I can't just cast it, okay? So I'm going to say reinterpret the thing over here and convert it to a character pointer. And in here, I'm not going to say nums.txt anymore because it's silly to write in a text file as binary. So let's call it actually bin so we know it's binary, okay? And I'm going to run the program. The program's going to run and it's going to write. But the difference is going to be this now. This is what I have. I have over there 4 doubles, back to back, bit patterns of them in a file. Obviously, you can't read it, but they're there. That's a binary file. That's how everything is. Text is human readable code. Nobody saves anything in text. Text is messy. Text is difficult to manage. Yeah, you feel happy when you open it and you can actually read it. But the problem is this. And by the way, like people at home, can you hear me? People at home, like 3 people.
Yep.
Okay, good. All right. All right. So let me just turn on the. There we go. Hello, everyone.
Hello.
All right. So when you are creating a text file, what are you doing, really? Think about it for a second. Say I'm holding employee name and employee number in a class. So my class is employee, right? And in class, employee or struct. Sorry, I don't want to start writing code. Okay, and this employee of mine has, I don't know, a size T. It feels so weird when I'm writing. I haven't done that for a long time. Okay, size T, that's employee number. They should invent a backspace for the board. Give me a second. You're going to tell me, so why don't you type? Because I'm going to just draw something? Employee number. And then I have over here character, name, say 50. Okay, so 50 characters for the name, yes.
You should probably turn off these lights.
Oh, yeah,
so you
you're
can see the-
absolutely. Let me see.
There you go.
Will you fall asleep if I do this? I'm trying to push the. Okay, nah, that's awful.
It's good as it.
Okay, okay. I'm just trying, man. I'm just trying. Okay, this is
Yeah, it was good, and then the flash hit.
okay. All right. So this is better now. Okay. All right. So if I have something like this, okay, now I want to create the file as text. So what happens is that if this is my file, so the file I'm creating, you know that file is just an array of characters, right? A stream of characters in the file. So this is the file that I'm creating. This is the file that I have. How far did I go? I'm good. Okay, so the first employee number, the size T is always the same, 4 bytes, right? And then the first last name is Lee, L-E-E. There we go. So this is where the first employee record is saved. And then I have a new line afterwards or a tab or something to separate the records. Delimiters, remember? Now I want to save the second one. The employee number is the same, but this name is Fardat Soleimanlu. Right? And I have obviously a delimiter over here, and I have another delimiter, a byte or something that I recognize this is the other one. And the next one is this, and the next one is this. This is how it's in a text file, right? And this is the last one. Okay? Now, if I want to find out, get to the fifth record, what can I do? I have to keep reading 1, 2, 3, 4. This is the fifth one. I read it, right? It is impossible for me to jump to the fifth one. I can't. Because the length of the record based on last name is always different. Do I make sense? It's a sequential thing, right? And it quite frankly sucks, because if I had 5 million records, if I want to find 4 millionth one, you know how many times I have to read? And searching through this is crazy. I cannot search. I have to go literally sequential search, and hopefully I hit something. Okay? But what happens if I write that thing binary? If I say, go to the address of the beginning of the employee and write it. What if I wrote in a file like this? So if I have employee E, I write over here file dot write, and I write the address. Assume that I casted the thing to character. Okay. So I write address of employee and size of E, right? And I write that. Then what happens? Then what does the file look like? If that's the case, I'm going to write it over here so I don't have reflection halfway through it. So if this is my file, this is going to be the first employee. This is going to be the second employee. Let's be more realistic. This is going to be the second employee. There are no delimiters in the middle. It comes right after the other one. This is the second one, and third one, and fourth one. And as you see, it takes more space because I'm writing 51 characters regardless. I'm writing the whole thing. But if I want to find the fourth one, I don't need to count. I'm going to say size of employee multiplied by 3. That's the number of bytes I have to pass to directly jump to the fourth one. I don't need to read, because I can find out where the address is and pick up the stuff properly. And that's the beauty of binary files. Obviously, lots of space is wasted. This is truncated, because if the name is short, it's smaller. If the name is big, it's so. But that can be fixed too. Don't worry about it. Okay? We'll see. That's called indexing. You have done databases, right? You have primary keys, right? What is a primary key and what is not? Primary keys are the ones that are fixed size, and the other ones are not. And anyways, you'll see. I'm going to write the code for you, and you're going to see what's going on. Are we okay down to this point? That's the reason we want to actually learn how to do binary stuff. Now, let's actually take a look at the binary implementation of what we have done. So now that I have written this, and I have that nums.txt with those values, let's actually put something. Yeah, so it's 10, 11, 12, and 13. These are the values that I have in there. We good? We okay? Okay, so now, yes?
So in the text file, it's actually omitting some of the decimal places. Like it's only 4.
Yeah, it could. We are lucky that they're all the same. One could be one decimal. This is decimal places that you're, and it's never precise because it's only showing the 4. But with double values, when you're putting binary, you are putting the exact bit pattern. So it's not even a billionth of difference between the two. They are always exact. With text files, if you do stuff with text files at the end and it's an accounting thing, you're going to lose millions because you don't know how it's being rounded, right?
So basically, what you're trying to say is that since the size is standard, if it is 1 or a million, it occupies the same in a binary one.
Yeah, in binary, a binary is a Xerox copy of data into the file. But a text file is a reinterpretation of the insertion operator of your data in the file. If you format your data, you're doomed. Because, you know what I mean? Like if you want to actually put number, like as prices, you only put 2 digits for cents, right? And all the other ones are lost in transaction, which means it's never correct. Okay? But when it's binary, you're literally putting the value that you have. And it's still imperfect because it's double. It's not exact, but it's much more precise than putting numbers. That's not even precision of a float with 4 digits after the decimal point. At least, you know what I mean? Okay, so what I'm saying is that now, that I have that, let's do this. So I'm going to do the exact same thing, but instead, what I'm doing in here is read. This is the old style, character pointer, okay? But you know that you shouldn't do that, right? We should write reinterpret, cast, character pointer, of V. The example comes from ancient times that I was teaching, so. So now, what I'm doing, I'm simply saying, open the file as binary. Now, read into the address of double V to the size of V. It doesn't care what's in the file. It goes to the beginning of the file and keeps reading 8 bytes and copies that 8 bytes to that piece of memory. And then it prints it out. Because what we created are those numbers, then what we print will be those values. Exactly. You okay with this? Okay? But the difference is that if now I set the precision of C out to 7 digits of decimal, the 7 digits after the decimal point, I can. But in the other one, I couldn't. If I read it, that's the data I have. This is now precise. See, as soon as I don't teach for a week, when I start teaching, I lose my voice. See that? I should have come over here with water. Anyway, so that's that. Now, not only that, now take a look at this. I'm going to say, so how did it stop at line 10? When it got to the end of the file, right? So now the file is in failure mode. Because it hit the end of the file, that's why it stopped. That's why I have while read. Read returns the OF stream, IF stream. And because it hits the end, it fails, and therefore it stops, right? You know that, right? So now I'm going to say file, clear. No, clear. Which means I know you're at the end, clear your status. I want to do something else. What do I want to do? I'm going to say file.seek G to size of V, say multiply by 2. You know what does that do? I'm telling the next get, you see that G over here? You know why they put that over there? This is the reason for it. Quickly tell you, anything that you use by the IOF stream, use W at the beginning, and it becomes wide characters, which means all the crazy characters that you don't have in the ASCII code, you can bring it in. All languages, you can write Hebrew, you can write Arabic, Farsi, anything you want. It reads it all. It's wide character. It's not a character anymore. And for that, you have to use WC out, WC in, and all your constant strings should start with an L at the beginning, L whatever. Or if you have a character, you put an L whatever. So, but forget about that. It's the same thing, just to be compatible with wide input-output system. Anyways, let's go back in here. So I stream and O stream. F stream is a child of both of these two guys, right? So they could have called the function seek in iOS or in O stream, right? In iOS, they could have created a function called seek to jump somewhere in the file, right? But wait a minute. iOS is input-output system. It's not specifically for files. So seek doesn't make sense over there. Seek only makes sense when you're actually going through files. Seek essentially means go to. Okay? So they created it over here. Now, if they both call them seek over here, then in here, you had to qualify it. You had to say, I stream scope resolution seek this. And for O stream, you had to say, O stream scope resolution seek. Too many characters to type. C programmers don't like that. They said, the heck with it. Anything that I'm reading, I'm going to put a G at the end for getting, not forget. For, pause, getting, okay? For to get, they add a G. To write, they add a P for put. So seek G is all the seeking for reading. Seek P is all the seeking for writing. All right? Just be aware of that. So any example that I'm giving you for reading, you can apply writing to it. There is no problem with it. Okay? Back to the example. So now in here, I'm going to say, go from the beginning of the file, go to the address of double multiply by 2. What does it mean? I skipped 2 doubles. So when I read now, I'm going to read the third one. Correct? So I'm going to have this. So if I run this program now, you'll see that it prints everything. Now I'm printing the third one. Third one? How many did it have? Why is it showing 3? No, it should. Let me see. What did I write? Size V, 2, third one. What did I do? No. I'm not right. Am I writing? No, I'm reading. 1, 2, 3. Size, seek G. I'll find out. I don't know. It doesn't make sense. It should be the third one. Yeah, end of the second one will be beginning of the third one. Anyways, I'll find out. Okay? So let me just bring the whole thing out. I'm not going to type it one by one. There's a reason behind it, whatever it is. So essentially, these are the things that I want to do. I think I had more stuff in the other one than this one. This is only 4 of them. Let me see. So I'm seeking over here. There I'm reading the character going into here. Then I'm reading the third one. Now, OK. Now, when you have seek with 2 arguments, the second one is direction. OK? When you have seek with 2 arguments, the second one is direction. The first one is absolute address. The second one says from where, what offset. So I'm saying from the end, go 0 bytes either further or backwards. It means go to the end, right? It means I'm saying from the end of the file, go 0 bytes further. It means at the end, right? Now I'm going to say, tell me where you are. And that will be your file size. Okay? So running this, give me a second. I want to see what is the binary file that I tested at home. I think it should be the same. So let's go through it one more time. So now, 1, 2, 3, 4. So I think it's more now. So this one has more data in it. Okay? And I'm printing them one by one. So these are the values I have in the binary file now. Now in here, I'm printing the third one. Now it's correct. I don't know why it didn't work in the other one. I have to find out later on. So it's actually getting the third one. So I have 4 data over there. I put different sizes. So it goes to the third one. Now I am at, where am I? Where's the execution line? Oh, it's not on the screen. It's here. This is the one. So I'm going to say seek to the end and stay there and tell me what is your size. What is your location, right? So if I do that, when I print that one, that becomes the size of the file in bytes, which is 8 doubles, 8, 8, 64, right? 64 bytes. Funny thing is that if you actually look at the properties of the file, if you look at the properties of the file, it's 1 kilobyte. That is 1024 bytes. That's because on a hard drive, unlike your memory, it's a physical thing, right? It's reading from it and writing into it. It has segments of data. So the smallest chunk that it can read is 1024, depending on what is the segment of your hard drive. But if you actually look at the property, it tells you that it's 64 bytes. You see that? And it says size on disk 0 bytes. So that's the marvel of Windows. But anyways, it's 64 bytes, but it has no size. It's like, anyway, so it's probably because it's open now. It cannot detect what is its size. Because I have it open over here, it doesn't know what it is. But anyways, let me put it back. So that's that. Now I'm going to say, from the position. What was the position? End of the file, right? Minus size of B. What does it mean? Come one backwards. So now if I print, it's got to be the last one. Correct? Now I'm going to say go to the beginning 0 bytes further. It's the same thing as saying seek G0. So the two means the same. I have 3 things. I have iOS beginning, iOS current, it means where you are right now, CUR, and iOS end, it means end. Read the document, please. Okay? So in here, I'm going to say from the beginning, go to byte 0, which means the beginning. Now, I'm going to say read 1. Obviously, this is going to be the first one. Whoa. Correct? Now, I'm going to do another way of reading the last one without tell G. I'm going to say seek to the end and come size of a double backwards. Do you see that minus? So the offset can be -2. If you're at the end, you can come backwards. So essentially, I'm saying go to the end and come to the size of double backwards. Now I'm reading the last one. That's a beautiful thing for a question and test. I'm going to say, I have a file of 5 million employees. Print the last one. All you need to do is do a seek G to the end and come back size of an employee and read it and print it. 2 lines of code, right? Okay, so, and now the last one is printed. And I have 2 return statements for some reason. Yes?
Is the cross to stream off or stream offset for going to the minus?
I think in C++ 17 and later, if you put minus in front of size of, it won't accept it because it's an unsigned value. Let's try it. Let me stop it first. If I recall correctly, all these types are going to drive you. No, it's okay, actually. Is it? Field errors. Unary operator applied to unsigned type result. Yeah, you see, result is still unsigned. Because you are doing minus unsigned, the result is not going to be negative. That's why you have to first cast it. And that's why I'm doing a static cast, because they are all numbers. It's not different. It's not a reinterpret cast. It's a static cast to stream offset, so you can go backwards. They put new names for stuff. Offset is simply an integer. Okay, the other one is an unsigned integer. Okay, but we have to name it properly. Anyways, that's type to you. Okay, are we okay down to this point? You okay? Hopefully. Okay, so binary random access. So when I say random access, people think random access means read and write. Read and write is not random access. Random means random to access where in the file. That's why it's random access. Okay? I hope I can get to the end of the thing. Next. Yeah, therefore, if you want to find the size of a file, all you need to do is this. Another beautiful question for a test. Okay? Write a program that prints the size of a file. And you have to do an argv argc up there, receive the file name, then open the file. If you find it, then you do a tell G, and you find out what is the value, and you find out how many records in a file. This is actually what doing that. So it's actually finding first what is the size, then it dividing the size to the size of the record. Then you can see actually how many records you have in a file. (64) and size of a double is so the S. It's what is S? So the what is it? 64 is the. So I'm going to say size of file, and this one is that's better interpretation of what it's doing, right? So file is 64. How many do I have in it? 8. Yes.
So if the file is a binary, how will you explicitly know that it's double?
Because I created it.
Because
Absolutely no way to find out.
no way.
No. I'll give you a piece of memory. Can you tell me what's in it? It's all ones and zeros. How do you know what's in it? You could through some. That's called encryption. You have to try to decrypt it and somehow find out the pattern, and it's a very difficult thing to do. But yeah. So I don't know. I could just read that one by one and print it as a series of characters, and I don't know, integers. Some values would come out, but yeah. It's going to be all garbage. So that's Yeah, exactly. CD, so that's file size and number of records. You are essentially looking at the questions for your quizzes that are coming up. Small questions, coding questions to see. So if you do all these things and try all these things yourself, you have all the questions for the quiz. I'm going to tell you that I have a data file, and they have 500 employees in it. Assume employee is overloaded with cout to print to print it on a screen. If we know all these things, print the 256th employee in the record. All you need to do is to open it up. You know, employee is the type. Open the file. Seek to the size of the employee. Multiply by the number of records. Read using the format that we had, and then print it out. Okay? I'll show you actually right now. Questions down to this point? Suggestions? Objection? An important fact. The mistakes I always made in my programming, and I had to debug it for 9 years, those are the things that I teach in class. Seek does not fail the file. Careful. I'm saying fseek to 1,000 size of a double. It doesn't fail the file unless you read. So seek essentially tells the file where to need to read next. It doesn't know that it exceeds the size of the file until you start actually reading, and it fails. It's like I'm telling you, step 200 steps to the wall. Okay. And then you start walking. 20th step, you're going to hit the wall. You say, what the heck? It's like you're blindfolded. You follow? You good? That's the example for it. So I'm just showing you that if a fail thingy never happens. So I'm saying read, that's the first one. Now I'm going to say seek to the 1,000th one and go back, read again. Obviously, because I seek to the 1,000th, it can't go there. But it's not going to fail the file. Fail only happens when it reads. You understand that?
That's why it's a loop. The loop enters the.
Yeah, so what happens is that when you seek, don't think that I can seek and detect if I'm at the end of the file. You can't. You need to really know if you are, you have to actually perform a read action to see if it failed or not. Or you find out what the size is at the beginning of the program and do the math yourself. Yes?
What if CD doesn't have any arguments? Variable the same as seek, like PD1?
No, there's no such thing. We don't have that overload. Seek is either 1 or 2. And the first one is stream offset all the time, and the second time is the direction. Second one is the direction. So the first, when it's only 1 argument, it's stream position. When it's 2 arguments, the first one is offset, the second one is direction. Okay? You can actually, you can do it like this, and you'll see. See? I'm going to say file.seekg. Come on, you should give me something. Now that I want IntelliSense, 2 overloads, it doesn't tell me which one. Son of a gun. Anyway, yeah. But believe it, it's just 2. Okay. All right, so seek does not fail if goes to outer bound. I love my file names. Very short and sweet. Okay. All right. Now, let's bring some stuff in. You want to go for a break? Anybody wants to go for a break? Yes? All right. So break 5 minutes. I'll end at 3:05, 3:10 to pack my stuff. So don't stay out too long. 5 minutes. And remind me to resume recording, please. Resume recording. So I brought a class in called employee. Now, if you look at the employee, this is what an employee looks like. It has salary, employee number, and especially I'm mentioning that this is not dynamic memory allocation. So the name of the employee is within the employee. Therefore, when I write the employee in the file, by the way, what is the size of a class? Does the methods of the class, do they occupy any space? The answer is no. It's like if no matter how much skills you have, it's not going to add to your weight. It's the exact same thing. So what a class can do has nothing to do with its size. Therefore, the size of employee is a double and an int and a character that is 52. That's what it's going to be, plus the alignment and things that we learned. Okay, so it's going to do the math itself. You don't need to worry about it. So I can do a regular OOP345 type of a write in here. And write the employee in a file, employee.txt. So I create a vector of employees, right? And I'm opening an OStream file, employee.txt, and I'm going through them and writing to them one by one. Because the insertion operator is overloaded for an employee, however it's supposed to be inserted into OStream, it will be inserted into OFstream. And the result of it, hopefully, if I don't get any error in here, will be 3 years later. Where is it? Employee.txt, which is this file. You okay with this? This is a perfect example that the records are not equal in length. And for some reason, as humans, when there is a backslash in and it goes to new line, we think it's a huge space between. No, it's just one character delimiter, and the other one is right after it. You know that, right? So the delimiter in there is so we know that. And if I actually open this file, so now, so this is so this is F, employee text out. So now what I'm going to do in here is this. I'm going to take this out. I'm going to say, open, this is binary. And when I'm writing the thing, instead of writing it like that, what am I going to do? Exactly like the thing that I've done. I'm going to say write static reinterpret cast of constant character pointer of the address of employee and size of employee, or whatever. Well, I'm writing EM, right? What's going on? EMP, stupid compiler. Okay, so EMP. So I'm doing the exact same thing. Obviously, it's not going to be TXT. I'm going to write over here binary, right? And when I run this program, now I'm writing all the employees in a binary file. We okay with that? Okay, so now if I look at the file in here, this is going to be the outcome. So you can still see the text thingies over there, but there are no delimiters anywhere. And if you look at all the things, they are exactly the same pattern. They start at certain thing, and the length of them, size of everything is exactly the same. It keeps all the extra 52 characters, the extra characters to the end of 52 after the size of the thing. But the importance over here is that the records are the same size. Are we okay down to this point? Are we okay? All right. So if I want to have random access to a text file and read the values for the text file, what it's going to look like. I want to read any employee anywhere in the file. This is the function that I'm going to write. I'm going to say, tell me which employee you want. That's the row. And I'm going to say, give me the file stream that you have. OK? First of all, I'm going to clear it in case it's at the end, because I want to, in case you hit the end, I want it to have a fresh new one. Then I'm going to say, go to the beginning. Now I'm going to start reading to the number of rows. Right? Take a look. So I'm just going to keep reading. If they want 50, if they want 50th employee, I'm going to read 49 times until I reach to that one, and I'm going to read that one. I'm going to return. If I didn't fail, it means I read it. If I hit the end, it means it was out of boundary, right? So essentially, this is doing kind of a read-only. But think about it for a second. Yeah, but think about it for a second. If let me just come over here and write a few things over here. So how many records? Oh, I don't remember how many it was. I'll put 15 in here. OK? So when I run this, it's reading from the text file, and it looks like everything's beautiful, right? So what happens, it starts from the beginning, prints one by one, but when it comes over here, what you see over here, that the whole 10th one is printed, and the 5th one, 50th, so it looks nice, right? I did random access. No, I didn't. When I was reading the first one, I was going to the beginning, count, come to the 10, and then print that one. Second one, I cleared it. I went all the way to the beginning, counted 5 times. And for this one, I went to the beginning, counted 15 times. So I went 30 times reading employees in an employee of 19 employees. And it's disastrous. It's slow to the bone. Like if I really had over here 5 million employees, you would have sit over there waiting for me to, Seriously, it would take a long time. Remember, this is a hard drive you're working on. It's not memory, although it buffers and stuff. But still, it is physical read. That's time consuming.
So it still uses the logic of tape, basically.
Yeah, exactly. It's like the old times you had, remember, like, how old are you?
35.
We used to have, I programmed an IBM 360, believe it or not, with rails and so as memory it would go. So I'm that old. So yeah, so like it was literally like cassette tapes. If anybody remembers what a cassette tape is, anybody ever seen a cassette tape? It's like that. If you wanted the 5th song, you have to go to the forward and try to find, that's essentially what I'm doing here. You just don't hear that. You don't hear that. That's the only difference. Okay? So how do we fix this? First, we save it as binary. And this, what did I do? And this would not have worked if I want to edit the file. Think about it for 2 seconds. Let's say I want to change the 10th record that is Chip Davis for that Soleimanlu. What would have happened? Because the data is sequential, half of my record will come override Joey Crusher over here. So it's only for reading that I can have random access. If I wanted to write, I would have screwed up the data. And even worse, if I wanted to work, I could have done it. But for every single editing, I had to recopy the whole file. which means read one by one, write. When I reach to the record that I want to change it, then write everything else, delete the original, rename the new one with the old one. And I have done that when I didn't know how to do this. Okay? So, but if I want to read random, then what do I do? So this one is EFGH, employee random read from text. CPP. Oh, XPP will do too, but hey, I'll change it later on to CPP. Now that's random. First of all, I'm opening the binary file. But take a look at this. No loop. See what I'm doing? I'm saying employee clear, go to the address of row -1 multiplied to the size of the employee. So I go to the address of where I want to read in the file. I'm going to try and read it. If I read it, if I can't, fail. You good? And if I can't, I'm just going to cut off. So this works the exact same way. When I run it, that's where, if I actually hit enter over here, yeah. So it works the exact same way. And that's how those people who buy your program don't know what you have done. So one person does it like this, and the other one, and they say, oh, the other guy's writing it for 2,000. You're charging me 20,000. Why? They don't know what's happening behind the scene. Okay? So that's the difference. You can write program, the but it works thingy that all the students say when you're saying, why the heck did you do this? And but it works. It works. But this one is hundreds of times faster than the other one. It's not even comparable. And I can go halfway through, change a name completely, come back, and all the records remain intact. Absolutely no problem. You can even delete the files properly like this. What you can do, you can have an extra byte added when you are writing and set that one to mark of deletion. Or create what should we call it? A flag in the class called deleted, and set that to true. So if you want to delete a record, you set that to true. So while they're working, if something is deleted, it's just flagged as deleted. And when you read, if it's deleted, you're not going to read it. You're going to say record not found. And then at night, you write a batch command, batch file, batch thing, garbage collection program that reads all your files, throw away the deleted ones, and recreate a new file at night when nobody's working. Okay? That's called garbage collection. That's how Java deletes your stuff when you're coding. Okay? But it's not when nobody's looking. Your program's going to pause and garbage collection comes. But we can do it like this. Okay? Do we understand that? So that's random access. Now, any problem now to this point? Now let's get ready to think a little harder and go deeper in this thing. Employee, let me fix this. Where is that XPP that I wrote? Oh, here. Ha! It actually put a CPP. Give me a second, let me fix that. Okay, so I should have named it I, right? Yeah, I'll fix it later. So the other one's going to be J. So I'm going to remove this employee now. And I'm going to add another one. Call it the employee. It's not the employee, it's the employee. The difference is that, ta-da, the employee is dynamic now. That's when you're going to say, shoot, what am I supposed to do now? Why? The reason is this. I think I'm going to explain it, and doing it's going to be for the next, for after your quiz. But we'll see. What do I want to do? Yeah. So this is when we did the employee. You had the thing, I drew it before. Well, problem is that when your employee looks like something like this, so these are your employees in the memory, all nice and dandy, same size. But the problem is that each one of them is pointing to a different size of name. So when you have something like this, what is being saved in a file at the moment of its execution is this, right? It's the exact same thing that you have rule of 5 for. When you have rule of 5, what do? You create copy constructor, move constructor, copy assignment, move assignment. Why? To take care of the data that exists outside of the class, right? So it's not move constructor, but you have to manually design something to take care of that. So what we do when we have something like this is as follows. When I'm writing this, I'm gonna, so this is, say, this is the record I am putting the employees in. This is the file the employees are being saved in. What the heck is this small thing that I have written over here? So this is the employee, right? You know what I'm going to save after each employee or before, whatever I want to do? The second file. So this is going to be employee.bin. The other one is going to be employee name, if I can write it, name.bin. And in that one, this is the name of the first employee, second employee, third employee, and fourth employee. With no delimiter. What do? When I save the employee, I do a tell on the file and see which location is being written. I put the address of where it's being written over there. And the next one, and the next one, and the next one, and the next one. And obviously, I forgot, I need a second one too. You know what's the second one? The size of what I'm writing. So the size of what is being written in here will go over here, will go over here, and so on and so forth. So when I'm writing, I measure what is the data, and I'm going to write that one right over there. Easy, yes?
Just a question, if you have the starting point and the input, and there's no delimiter nor anything else that changes the length, wouldn't it be possible to just get the size just by the difference between the starting point and the starting point of the next one?
What if you want to sort the employees? Everything goes back and forth. You don't know which one is which. That's the beauty of binary files. When you hold the data in a binary file, you can now sort the employees, rearrange the employees, because each one is going to carry where the data is going to be, and life is beautiful. Are we okay? All right. So how do I'm doing this, and I see why the mouse is not moving. Okay, so first of all, let me wipe this up, because I know I'm going to be short in time, and the other prof is going to come in. So as you see, the write of employee and read of employee has two files, not one. Okay? It has two writes, not one. So it's not like you're writing a move constructor. You have to really engineer what you want to do, and different people may design different things. I don't know. But this is how I came up with this. There is no blueprint for it to do it, but this is how indexing works, essentially. So essentially, when I'm writing, this is what I'm doing. I'm going to say, first, tell me where is the position of NFS, the file that I have over there. Okay, what is the name location? And this is what I'm reading. Okay? So what I'm writing. So I'm saying where is the location of that? What is the tel-p on that one? This actually is wrong. It's going to fail. This write is assuming it's not going to fail in my example. It will work with my example. But it's not going to work if the program ends and you want to continue appending to the file. So what I should have done was actually this first. I should have said NFS dot seek p. I'm not going to execute it. We're going to come. I'm going to explain it the next day you're coming in. We're going to go through it. So I'm going to say seek p0 and iOS end. Now it's going to work. So I'm going to say go to the end of the file, wherever the end of the data file for the name is. Tell me where it is. Tell me what is the length of the name of the employee. Now, in the NFS, the very first thing that I'm going to do, I'm going to write the name and the length. So that's another function that I have written that just writes the name of the length into the file. So that's going to be written. Then I'm going to write into the, so that's the first one is name. It writes the name to the length. So the name will be written in the name file. Then in the data file, the size of the object will be written, and then the location, in the location of the name will be written, the size of name location, and the name length. So I write the location of the name and the name after I write the data. So I write exactly the same thing. Oh, I wiped out the picture. Exactly what I've done. So first I write the employee, then I write what is the location of its name, then I'm going to write what is the size. Then I'm going to return if both were successful. And so this is how I write. For read, what I will do, first I will read the employee. Then I will read the location. Then I will read the name. Then I will read those information and dynamically allocate and put it for it. Okay? It's, I know, too complicated. I'm going to put it up, walk through it. First, write it. Go through it, write. Or I'm not going to put it. Should I put it? Nah, go study for your quiz and stuff, okay? So I'll remind me to start from fastest with resources writing, okay? It's too much. I thought that I'm going to reach the file system, but I could not. File system I'm going to talk about. So it's only this and then file system. File system is easy. 2 seconds, I'll go through it. Anyways, have a beautiful day, everyone.
Thank you.
Thank you. Yeah, later on. Okay.